Hello, my friends. Let's make this key. Mrs. Key. Determine the zeros for the function below and the multiplicity for each of the zeros. So for the zeros, take each expression. So first one's x equals 0. X minus 5. I don't need those parentheses. I can get rid of those. Boop, boop. So take each expression, set it equal to 0. And then the third expression is 3x plus 1. Solve each of those equations. Well, that first one's already done. The second one, add 5. Don't forget an equals 0, which I totally did. And on the third one, subtract 1 and divide by 3. So if you do that, that's the zeros part. So we determine the zeros. Those are the zeros of the function. This one would have multiplicity 1, because look, it just is an x. This one would have multiplicity 2, because there's an x squared, or something squared. And then this one has multiplicity 3, because, wait for it, oh, there's a 3 right there. P of x is the product of two functions given. Identify the zeros. So the zeros of P of x, if the P of x is the product of the two things, the zeros of P of x are the same. So negative 3, actually I can just, don't have to write them as coordinates, I can just write x equals negative 3 and 0. Determine where P of x is positive or negative. So I'm going to, not there, I'm going to break things down this way and this way. And I'm going to say, if I take a, let's see, I have green and black. So I'm looking at the green first. The green is positive because it's above the x-axis, positive, and then negative. So green goes positive, positive, negative. The black goes positive because we're above the x-axis, negative, positive. So if I do positive, negative, positive. So black goes positive, negative, positive. So that means that my new function, which I will make yeller, is going to be the product. So positive times a positive is a positive. Positive times a negative is a negative. Negative times a positive is also a negative. Ooh, spicy. So we're going to have a so I just did that part to note the positive, negative, positive. Now I need to graph it. So I need to come from the positive, so that means I need to go up like that. Then I need to be negative, and I need to stay negative. So I need to go down, but then hit there, but then stay negative. So I bounced right there. I hit that 0, but I did not go through. I went through there and not over there. And that would be my graph. So I've done all the pieces for that. If you're confused about the positive, negative thing, feel free to talk to us. It's about the location of the graph. So anything above the x-axis, so the x-axis is right here, anything above the x-axis is positive. So green is positive, and then green is negative. Black is positive, and then black is negative, and then black is positive again. State whether the graph represents a function that is even, odd, or neither. Okay, so I'm going to write down what that means. So even is symmetric over y-axis. Odd is symmetric around the origin or about the origin. That sounds a little weird. And then neither is not those. So not those. Not symmetric about the y-axis or symmetric about the origin. So if I looked at this graph, if I picked this point right here, this point is 1, 1. If my function were even, I would need to have the point negative 1, 1. I do not. If my function were odd, I would need to have the point negative 1, negative 1. It does not, oh, it's not negative 1, 1, I'm sorry. Check out that scale, Mr. Butterworth. What are you doing? I'd need to have, that's 1, 2.5. So I need to have a negative 1, 2.5, which I still don't have. And then a negative 1, negative 2.5, which it doesn't look like I have. Let's check another point. It looks like I have the point, oh goodness, that's not even 1, Mr. Butterworth. That's 0.5. 0.5. 0.5, silly scale, silly scale. Pay attention to your scale. Mr. Butterworth did not. My reasoning is still good, but my scale is not. So it doesn't look like I have that point. So let's say, okay, it looks like I go through, I'll call that, this is actually 1 this time, 110. Even was already out, so we're not even. So we'd need to have the point negative 1, negative 10. Well, at negative 1, it looks more like we're at negative, I don't know, almost negative 15. So we are neither even nor odd. If we were even, we would have the same thing on both sides. So if we had 110, we'd have negative 110. If we were odd, we'd have 110 and negative 1, negative 10, which we do not hit. So neither. Sorry for messing up the scale. I apologize. Function for h is given. Write an equation for the transform. Transformers. In terms of h of x. Describe the transformations performed. All right. So I'm going to do it I'm going to do two different kind of views on this. So one transformation is left 4. I know that because I have an x plus 4. And what makes x plus 4 equal to 0 is negative 4. So I go left 4. My second thing is vertical stretch by 2. And then up 5. Those are my vertical transformations. So vertical stretch by 2, multiply all the y values by 2 so things get taller, and then add 5, so move the whole graph up. That would be what's going on. And that would be a good explanation. There are other ways to, verbalize some of this, but that would be kind of, I think, the easiest way to think about it. I hope this has been helpful. If you have questions, make sure you reach out to us and ask.